Okay, let's talk about your model, your forecast. How long will it take for the Philippines, based on your model, before we can flatten the curve and put things under control?
There are several things that I need to tell about the model first because it's important that we know the ground truth. And the current issue that we have right now is that it's not so clear because we are not yet testing as much as we want to test. There's some backlog. And therefore, that would be the limitation because it's very difficult to see where we are actually in the epidemic curve based on the model because we cannot ascertain 100%. Just by looking at the actual reported cases, one way to deal with that is to look at the number of deaths because the deaths will give you the idea of the case fatality. If you have heard of this, they say that the case fatality rate, which is the number of deaths over the number of cases, is unusually higher in the Philippines. It's because we are not yet testing as much as we can to know the ground truth. But for your question, can we flatten the curve? There are several bases for that. Several people have also modeled. So I'll be answering based on compiled answers. It will take us several months to really flatten. And based on the current data that is being generated from the Philippines, we have not yet flattened the curve. And we need few more months to completely flatten the curve. So at least few more months.
When you say few more months, how many months exactly?
The estimate would be around 2 to 3 months before we could really flatten the curve. But I'm still waiting for the current data to see whether. So when we say flatten the curve, it's reducing the number of cases. There's a threshold that we want to reach. And the threshold that we want to reach is the healthcare capacity. And the implication for that healthcare capacity, in simple terms, is the number of ventilators for severe cases. The estimate, according to a meeting I attended early in the morning here, 4 a.m. in California, is we only have 1,500 ventilators, right? And I think 500 of that is in Manila. So if our severe cases went beyond that, it will be like Italy. We will be selecting who will die or not. My estimate is that to prevent the current trajectory, we need a few more weeks and months to reduce that so that we will not overburden our healthcare, which is already struggling as of the moment.
Okay. Now, you mentioned earlier that, of course, this modeling is based on current figures by the current data from the Department of Health. So, meaning we're still testing more patients to look for COVID positive cases. So what was the fatality rate that you use in this model, and how credible is the model that you came up with?
Okay, let me explain the model. So there are two things that we're doing here. We're generating the model, which is a representation of the epidemic. And based on that theoretical model, which is using, in infectious disease model, we use the SIR or SEIR. I use the SIR. SIR stands for susceptible, infectious, recovered. So you transform so I use the R naught. So the R naught, or the reproductive number, is the average number of secondary cases from single case. So I extracted that value from the Philippine reported cases, inputted it with the model as part of the transmission parameter, and that gives us an estimate of, based on the current trajectory, what would be the approximate number of cases. So when I generated the model, I now use the actual cases and compare it. So you have an independent mathematical model based on the transmission parameter, and then I overlay the mortality and see if this is the number of the cases, what would be the estimated mortality based on this approximation. So I always compare. So the mortality is not an input to the model, but I compare it based on the number of cases. I hope that is clear. So the mortality is not an input to the model, but I compare it with the model.
Okay, but what R naught did you use?
My computed R naught is 2.5.
2.1, 2.1, 2.5.
I think I was the first one to release it publicly.
2.1 or 2.5, sir? 2.1, 2.5. Okay. Now, the other important question, how many fatalities, unfortunately, are in your projection and how many more infections will there be, again, based on your forecast, before we flatten the curve?
So the estimation of mortality, we usually use range because the mortality rate differs across countries. So there's a mortality rate in Korea,
Yeah.
there's a mortality rate in Italy. Now, let's just put context to it. If we overburden the healthcare system in the Philippines, mortality rate would go higher because we will no longer be able to service those who are severely ill. That is the case for Italy. But if it is in the case like South Korea, I think the latest estimate is 1.7. I think that's all. But the figures are dynamic, so we will have just to double check on this. But higher values can be 8 or 9 depending on the healthcare system. So that is the range. So if I provide the number, for example, in my model, just to put context again, is a do-nothing scenario, meaning we don't implement lockdown. The peak number of cases in my estimate is around 250,000. That includes the asymptomatics. But the approximate estimate is 1 to 3% of the 250,000 would be severe cases. So
Again,
that's the context of my predicted model.
but that is in a do-nothing scenario.
Yes.
Okay. Pero dito with the current, what measures should be put in place here? And based on your forecast, would you suggest an extension of the enhanced community quarantine?
So I will be basing my answer based on several models. So one of the key reference that we are using now is Ferguson. Based on Ferguson's suppression strategy, so in what they proposed is they do ECQ-like intervention for several months. But the moment you remove the ECQ-like suppression strategy, total stoppage of schooling and other social distancing intervention, the epidemic curve will peak again after 2 to 3 months once you remove. That is on a 5-month basis. So if we remove the ECQ on April 13 and we resume normal activity at April 14, the epidemic curve would rise again. So based on these predictive models, I wouldn't recommend based on the data.
You wouldn't recommend what? Ending it or extending it?
I wouldn't recommend removing it, so it should be extended until we meet the following conditions. We have the necessary healthcare capacity in terms of hospital beds, in terms of ventilators. Those are the critical elements for me. Another one is until we can enforce social distancing at public transportation properly. If we can implement proper transportation, social distancing procedures, disinfection, we can probably slowly introduce back to normal life. But I wouldn't recommend opening school as of the moment because based on several studies, opening school would promote further spread of the disease. And I think we don't want that to happen.
Okay, Dr. Darwin Bandoy, thank you very much for joining us this morning, sir.
Thank you, Christian.